So number 12 in the homework set. So first thing you always want to do for these problems, set up a diagram. And on the diagram, you're going to show all the given information. So we got this car initially traveling at 20 meters per second. So that's what? V initial, velocity initial, 20 meter per second. And it accelerates, so this car accelerates with an acceleration of 4 meter per second squared for a distance of 50 meters. So that's our x. If you're really paying attention here, x, I told you last week, x is displacement, but displacement and distance are only different if the object changes direction. Like if this car turned and went somewhere else. But if it's moving in a straight line, it's distance and displacement are the same thing. Yo. Yeah. So the distance covered here is 50 meters. And then over here is the final part, the final spot. Okay, so V final is a question mark. So what we're trying to solve for here is the time. The question says, how much time is required to cover this distance? So what you're learning are the 4 motion equations, which I have written out, and I haven't decided if I'm going to make you memorize them for the quiz or not. I haven't taught regular physics in a long time. To be honest with you, I don't even remember if I used to have kids. What do you guys think? Memorize them, or you want to memorize? Do you guys want to memorize? Okay, so you memorize them for the quiz, and I'm so impressed with how much you guys want to learn. You know, I'll let you know. But anyway, here are the 4 motion equations. So let's go through them one by one. So the data we have is on the picture. We got initial velocity, acceleration, displacement or distance. We don't know V final, we don't know time. So we're looking for the time that this would take. So the first kinematic equation, do we have enough information to solve for time? We do, but there's a bummer here. I would try to avoid this if I were you. What would be the big bummer with using this equation for time?
T squared.
T squared and t. This is going to give you what, math people?
2 answers.
Not t cubed.
2 answers.
2 answers, but you're going to get a quadratic. To solve that, you'd have to use the quadratic equation. Does that sound like fun? No. So there's typically a way to avoid the quadratic. So let's keep looking. Could we use this equation? Nope, because what are we missing? V final. We don't have V final. Okay, could we use this equation? Nope, because we don't have V final. And then this one doesn't even have time in it. So look, if you want to avoid the quadratic, does everybody see what I mean by the quadratic? You got t squared and t. So if you want to avoid the quadratic, what you could do is first find what? V final, then find time. Does that make sense? So how do you find V final? Which equation could we use to get velocity final? The last one. So using that last equation, V final squared equals V initial squared plus 2ax. So V final, you know what? In my AP classes, I require that kids do the algebra before they put numbers in. For regular physics, I'm going to let you guys do it whichever way you're more comfortable with. But it's really to your advantage to do the algebra first and then put numbers in. You know what I'm saying? Because what variable are we solving for here? V. Well, that's actually a bad example because it's not too difficult. But do the algebra first, then put numbers in. So V final is going to be square root of V initial squared plus 2ax. So now put numbers in. So V initial is 20. Make sure you square that. 2 times the acceleration's 4. And then x is 50. All right, so this is going to give us V final. So that comes out as bless you. 28.284. Okay, so we now know what this is. V final is 28.284 meter per second. So now we can easily solve for time using, you could either use the second equation or the third equation. I think the third is the easier one. So VF equals V initial plus AT. So doing the algebra first, you're going to get V final minus V initial over A. So now plug numbers in. 28.284 minus 20 divided by the acceleration, which is 4. So 8.284 divided by 4. So the whole thing took 2.07 seconds, which is the answer.